Welcome back to our statistical learning session. We'll continue the test-based log likelihood from our last session. In last session, we talked about how we will use the y-axis instead of x-axis to check whether theta MLE is close to theta or not. Now, based upon that premise, how should we proceed? Can you tell me? Now, let me give you that answer. We should start with few things here. First, here we have to form our null hypothesis. And what is our null hypothesis? We are saying that there are two things, theta and theta not, and they have many vectors, coordinates, and for a subset of coordinates, we are saying that a coordinate of theta is equal to theta not. Now, next step is to calculate the maximum likelihood estimator. And how do we do that? Can you tell me? We can calculate maximum likelihood estimator by taking a log likelihood and taking a taking a likelihood, and taking log of that such that the theta that we put into that function gives us the maximum value of log likelihood. That's the definition of maximum likelihood estimator. To estimate the value of theta such that the likelihood function is the maximum value. Now, to that end, we write this. This is what we write to that end. Here, this is a likelihood estimator, log likelihood estimator, and we are taking maximum of that such that the value of theta is maximum. But if you look at closely, this has some constraints here. This constraint exists because we're not free to choose all the theta to get a maximum likelihood, to get a maximum value, to maximize the likelihood function. We are not free to choose any theta. For certain theta under H naught, we are bound to choose theta naught. That is, under a null condition, we are bound to choose theta such that we are bound to choose the theta such that the theta naught belongs to null hypothesis, and theta naught is such that the theta belongs to big theta, where theta n plus 1 in d dimension equal to theta naught n plus 1 theta naught d dimension. Now, what we are saying, what's the difference? This is a full maximum likelihood. This is a comprehensive or overall without constraint maximum likelihood. But this is a constraint maximum likelihood because we are constraining in theta such a way that a certain subset of theta is constrained to the theta provided in the null hypothesis, which belongs to theta naught. And that's why this is called constraint MLE. Now, what we have learned today, let me quickly summarize. We learned that we are testing the null hypothesis in such a way that the certain part of theta, a certain subset of vectors of a coordinate theta, is equal to the not theta naught, which has a specified, which we have to theta naught. And to begin our testing process, we need to get the value, or we need to define the maximum likelihood estimator. Overall, we have to first define overall maximum likelihood estimator, and on top of that, we'll define theta in such a way that we'll constrain the certain theta to theta naught, which is a which that was already defined in null hypothesis S naught. And once we do that, we get a constraint theta, which is maximized over constraint theta naught. And that's what we learned today. I hope you understood what I just said today. I will see you in next learning session. Thank you so much.